All right, so recording has been started. So today we are going to discuss where we left off in the previous session. Hi, Mandar. Okay, go ahead, Mandar. All right, go ahead. So Mandar's question is, as we can see that SED command is being used for parsing and unique is okay, but where exactly is the mapper job getting done? So is my screen visible to everyone? Okay, so Abhishek, it could be the problem with your own your connectivity. Maybe you should retry connecting. Everybody is able to see my screen. All right. So Mandar's question is that in our where was our streaming job? All right. So I hope you are talking about this one, correct? Right. So let me make the screen a little bigger. All right. So here you can see the mapper is this command and reducer is this command. Now if you see what does SED do? SED basically converts each line. This command is converting converting lines sentences or the converting to one word per line. Okay, so SED command converts the whole line into one word per line. Now, as we talked about, our expectation from any mapper command was that that command should convert the input text into key tab value. Okay, so any mapper, whatever is the mapper, they are supposed to give us. Okay, mapper gives us key, whatever is your key one, let's say key one, and then tab, or you can just press tab here, and the value. Okay, and mapper is supposed to give these kind of things as an output. When we are talking about, say, there is another key to, value to, and so on, right? But this command just gave us only words, right? There is no tab, there is no value, which is completely okay. So in case mapper gives something like this, it means that mapper has given only keys and no value. Okay, value is null. All right. Give me 10 seconds. I'm sorry, I got a little disturbed by a few things. All right, I'm back now. Now, so I hope that makes sense, right? So any mapper can give without value. Now our SED, any word you basically SED is giving us only the keys. And what are those keys? Those keys are one word at a time. Coming back to, but our intent, Mandar's point is, but our intent to send lines divided and send to multiple hosts. So that is the duty. So the role of any command you write, the command does not have to worry about sending the content to any of the mapper or reducer or anything. Command's duty is, the mapper's duty is to give the key and the value. All right. The now is the Hadoop's duty to take care of everything else. It's the duty of Hadoop to take care of everything else. Right? So Hadoop will take these, do whatever it wants to do sort it and send it for reducer and all of the process. Okay. So it's not the duty of SED or duty of any of the mapper, and that is the simplification brought in by Hadoop. Okay. So that the the developer does not have to worry about internal mechanics of mapper and reducer. So it is getting managed in jar file? No, it's getting managed by this command called Hadoop. Okay. So Hadoop is executing this streaming in a way that it will just pick up, it will try to find the mapper which will run it will run these mappers, and then okay. So most of the magic of execution is being taken care by Hadoop command. All right. Did it make sense, Mandar? All right. So yeah, so basically almost all the complexities of sending it to mapper, reducer, this, that, all of that is mostly absorbed by Hadoop itself, the way the execution is done. And Hadoop streaming does nothing but has internal mapper and reducer, which internally calls this command so this command, and this streaming job has a fake or kind of a dummy mapper class which basically internally calls this, and there is a dummy reducer class which internally calls this. Okay. Okay. So what exactly is the confusion, Mandarna? All right, Anuj, no worries about. Yeah, you can do the problem 2 assignment after the session, no issues. Okay. Anuj, are you able to hear me now? All right. Okay. Okay. Yeah, Michael's question is, can we have more time to do assignment? Yes, you can have little more time to assignment, but there'll be more assignments as we go forward. So there'll be too much of pending tasks. Okay. And yeah. So Abhishek's question is, if I have to do the reduce phase 2 times to get the desired output, then do I have to run 2 separate jobs? That is correct, Abhishek. Okay. E- I mean, either you can club both the codes into a single command. If you can't, that means you will have to fire a new MapReduce job. Yeah, you can choose not to have any mapper at all. If your input is already in the form of key and value, okay, your mapper can be as blank as reading the input line and just printing it out. All right. Any other questions before we move forward? Okay. No questions, so I'm assuming. So we discussed a little bit till the point last time up to working on Java. So did you get your code working in Java? Did you go through the video how to configure Java into Eclipse? Okay, Anuj, no worries. We had been discussing only few problems by other mates. So if you have any questions, we can discuss now. All right, so Abhishek was able to configure the project. So, all right. Okay. Okay. Shisha is done with the coding problem. Shisha is having accessing problem in accessing the cluster and running code using Hadoop. All right. We have not discussed the problem number 2. Okay. All right. So here we can configure the we configured the project. All right. Now we had gone up to this point. All right. What exactly does this page say? Any questions here? No. We'll talk about rest of the Java code again. All right. Now let's discuss the problem number two. Okay, Damodaran, no issues. Okay, no issues. Anuj, you can do it after this session. All right. Okay, so now let's have the discussion regarding problem number two, right? So one of the easiest approach, the problem statement, but first let me reiterate on the problem statement. So you are given a huge corpus of commonly used language. You are given a big text that is basically a big text of how people talk, what people talk about, a normal language, let's say a Wikipedia or some other form of text you're given. Now, based on that, you have to figure out what is the word, what is the commonly used words people use after a particular word. For example, if people type happy, the next, the most commonly used word after happy would be birthday, New Year, or something like that. Okay. And similarly, after how you have are, do, did, and those words which commonly occur after how. So how do you find out from if you're given a big text already? So you are given a history of how people talk, and then all right, this is probably the easiest approach you could have. Okay, you could have an approach like this where you break down each couple of words into this kind of sequence. So, how are you, Ram, happy birthday? Which means if there is another how in the text, that will become the key, and R is the value. So, how is the key, R is the value, next R is the key, U is the value, and so on. Which means the word for each word we are creating the key, and for each word that is for the word which is following each word is becoming the key value. Now all the words that follow how, all the words that follow how will come together automatically, because that's how the Hadoop works. Once we specify our key, all the words, all the values of the key come together. So all the words whose key is how will automatically come together, right? Great. Yeah, Srisha solved it in the same way. All right. Now, do you see any problems in this approach, Srisha? I know it's a bad news for you, but yes, it has got problems. Yes, go ahead, Savita. Anu's question is reducer might be very complex to do the frequency analysis. Correct. Correct. That is good, Anuj. Arvind says upper and lower. That's also correct. We can fix that by converting into lower. That's not a big deal. Very good. Savita says, why are we not splitting the statement delimited by dot? Okay, instead of splitting it by new line, why are we not splitting it by dot? Very good. That's exactly the intent of this question. Thank you, Savita. All right. All right. So if you look at this now, yes, Shisha says maybe memory usage for tree map. Which one is tree map, Shisha? Are you talking about when we are doing frequency analysis of the words in the values? Okay. Good, good. Yes, that's another problem, meaning the memory usage inside the reducer might go really high. That's correct. So here are the problems. Okay, now let me read out Mandar's question. Using Unix regular expression. So I think find word after how. Okay, okay, go ahead. All right. And we have got a very good approach from Anuj. He says that another approach would be to have the key as two words together, which means how are you? How dash are and are dash you is the two words together, and the value will be one. And then you count the frequencies of these words. Okay, and after you have counted these words, then you remove the words which are only occurring, say, once or twice. Oh, okay. So that way you can avoid lot of key value pairs which are redundant. Okay, that's a very good approach. Yes, yes, go ahead, Mandar. I want to understand your approach. If you could write it in a single shot. So what were you were saying? Using the Unix regular expression and find word after how, correct? Okay. Okay. So that will be like you are not utilizing MapReduce, right? If you try to pick up a word after how, find out all the words that are following how. One easiest way would be we pick one word from the text, find out all other words in the same text with the same name, and find out all the words that following them. And we do it for from top to bottom for each word. Okay, but that will be very inefficient. Instead, if we could just either prepare a hash table or something in which there is a key is your word and the value is something, but then again that will suffer from the memory overflow. Now the correct approach would be to break it down such that we can utilize the sort command or the sorting. If we can utilize sort command to solve our problem, that means we can also utilize Hadoop to solve our problem. Okay, so Michael, this is not clear to you, this translation. All right. I would like to understand what exactly is not clear. I would like to explain it more. All right. So there are these few problems which all of you have already come up. Computation of frequency is complex because again you have to do the word count in the values for each key, and that word count is again going to be a problem. Therefore, therefore, okay. So So when we are doing frequency analysis in the reducer, what we'll have to do is we have to count the words and we have to take top 5 words out of those. So counting the words could be really daunting if you think about the words like prepositions. How are you? In this, the the word are will have so many more words following them. If the key is are, the values will be so many. Or think about is, am, are, of, the values will be too many. Therefore therefore the computation of frequency in the reducer is going to be inefficient. Second is, last word of the line should pair with the first word of next line. Okay, as you have already said, uh, Savita has already said that instead of breaking the input text in by new line, we should break down the text by dot, which means instead of doing line wise processing, we should do sentence wise processing. The last word, okay, it's the same thing again. Yeah. So, all right. So Subbareddy's question is, why can't we include Happy Birthday Ram? Where should we include this, Subbareddy? So our overall objective is find out all the words that follow a particular word. And the approach here we have used is split the line into pair of words, okay, such that and pair of words so that when when Hadoop runs, Hadoop will bring all the keys together, and therefore all the values for a word will come together, which means all the words which are following each of the words are going to be coupled together. All right. Now, Santosh's question is, wouldn't the input just be the group of words from Wikipedia? Would there be sentences in the input? The When we talked about the text from Wikipedia, it will be the full sentences, not only the words. Okay. Now, question from Michael is, how is Ram being mapped to happy? And what about you and Ram? Yes. So those are the problems in this approach which we have just taken, because by default, what Hadoop does is Hadoop gives you line by line output. Okay, the mapper has only access to a single line at a time. That was our problem. If you have seen our reducer code, sorry, if you have seen our Java code or our um, streaming code, our mapper does not have access to more than one line at a time. Therefore, we need to do something about it. And these problems, like why is Ram and Happy being coupled together, or you and Ram is not being coupled together, we need to solve that problem. All right. Now, is it's clear to you, Michael? All right. Okay. So before we go forward, let's just see if you are with me, or is there a disconnect between all of us? All right. Now, okay. So question to all of you is, if you are not nearby your keyboard, then come over to the keyboard, because there are going to be a lot of questions. All right. Now it's my turn to ask questions. Okay. Okay. Arvind's question is how to combine two words. You can combine two words by using some separator, some special character. Okay. So the data generated by mapper is given to reducer, and then it is sorted and shuffled. Michael and Santos. I think Santos has corrected himself. Okay. So, Girish, is it yes or no? Ouch. Savita, Girish, and Mandar, just have a look at the question again, please. So, the data generated by mapper is given to the reducer code, and then after reducer, it is sorted or shuffled. You remember the diagram we talked about earlier? Yes. So, no, the output of the mapper is first sorted or shuffled, and then the reducers are called. Okay, Mandar, Girish, and Michael. You remember our diagram which we talked earlier about? Great. Now, the mapper can only generate one single key value pair for an input value. Is that true or false? Okay. So, Abhishek and Anuj, so is that true or false? So, if you remember, our mapper in case of word count generated how many key values for each line? Only one or multiple? Great. So everybody, yes. So it's false. Mapper can generate as many key value pair as it wants. A mapper always have to generate at least one key value. A mapper has always have to generate at least one key value pair. Anybody? So give an answer in correct and wrong because I might confuse it with the previous question. Correct. This is wrong. Why? Why? Because let's say there is a particular line. It's up to mapper whether it wants to spit out or it wants to give out the key and the value. Okay? Mapper can choose to give no key value pair at all. Say there is a line which contains only a single dot. And in our word count program, we are say removing all the punctuation characters. Therefore, there is no point of giving out any word, right? Therefore, therefore, the answer is wrong. By default, there is only one reducer in case of streaming job. Yes or no? Arvind says it depends. Okay. Yes. So by default, in case of a streaming job, it assumes a single reducer. Okay. There is only a single reducer in case of streaming job. If you remember, we if you do not provide any argument about how many reducer we want, it always has one output file, which means one reducer. But the moment we say we want these many reducer, it automatically create those many files. Okay. All right. That's correct, Urs. That default number of reducers can be adjusted, but the default ones are one. All right. What is the role of job tracker? Executing the map reduce logic or delegating the map reduce logic to task tracker? Great. So everybody is correct in this. The answer is B. Second. Now the question is, map logic is executed preferably on the nodes that have required data. Is that yes or is that no? Great, great. So the answer is yes. All right, awesome. Now here is the keyword is always. Map logic is always executed on the nodes that have required data. Correct or wrong? So question here is map logic is always executed on the nodes that have required data. Meaning if there's such node where such node is very busy on which the data is, then our logic will not be executed. Is that correct or wrong? No matter what happens, map logic will always be executed on the nodes that have the required data. Is that correct or wrong? Or let me reword it for those who have marked this correct. If the node on which the data is there, if that node is not available, map logic will not be executed. Is that correct or wrong? The answer is wrong. Because I always said that map logic is executed. The tendency of yarn is to execute your map logic as close to the data as possible. Meaning, if the, so as our mapper has to convert the input data into key values, so there'll be a transfer happening. There'll be a transfer if our mapper is executed on the node which are away from the input node. Is that clear, Girish? Now? So here the keyword is always. So that is why this statement is wrong. Yes. In case the node, that is correct, Srisha. In case the node on which our data is, in case that node is very busy, or let's say there is no task tracker running on that node, then the data will be transferred. Data will be transferred while executing the task tracker on a nearby node. So Arvind's point is, so Yarn first checks whether the node is available to transfer the data. So Yarn first checks whether the input data, whether the node on which the input data is, if that node is available or not. If that node is not available, then it finds the nearby node to our data, preferably on the same machine or in the same subnet. Okay. Yeah, that's correct, Damodran. If that was your impression, if the map logic node is busy, then the map logic will be executed on some other node. Okay, so your this is correct. So the same thing is here also. All right. Now Anu's question is, if the data node is down, can you explain the scenario? Good point. So let's say there is a data node, one of the data node is down. But if you remember correctly, if a data node is down, that particular block of data will be copied to some other data node, right? And let's say, uh, okay, so that way that's how it will be resolved. But let's say while the mapper was delegated for the execution on a node, and this node got shut down for whatever reason, what will happen is, since our job tracker will stop receiving the heartbeat. Therefore, it will assign the same work to some other node. Okay, Anuj, did it make sense to you? Yes, that's correct, Santosh. That logic can be executed on other two nodes where the data is already replicated. That's correct. So what happens is, It will try to first find out the node which has the data. Let's say it find out there are three nodes which have the data. Now out of those three nodes, it will first find out which one is most free. If none of those three nodes containing the replicated data, if none of these three nodes are free, then it finds out what is the nearest node available. Okay, all right. If the data cannot be accessible to read the data as well. uh, okay, was I able to answer your question, Anuj? Now I think, Santosh, I've answered your question. Okay, so will the new node have the replicated copy? All right, I think you all are right in this. Okay, okay, no worries, Michael. All right, so everybody's clear. Do we have any other questions? Just a second. Give me a second. You can ask your question in this second. So we have a question from Savita. Okay. Yeah. Savita's question is that in between the job, the data node goes down. Does it automatically reroute into new data node and complete the job, or does the job fails? Yes. So in case, say there are three data nodes. So let's say the work was delegated to three different machines, and one of the machine has gone down, and the work will it will automatically get rerouted to another machine which is up and is having the data. Or if there is no machine which has the data, I mean, none of the machines which have the data is available, then the machine which is closest to the one which has the data will get the work. Okay, and that is why, because of these kind of strategies, the work at MapReduce is called the MapReduce is called batch processing, because it is basically doing all the fail-safe activities. Okay, and that's why sometimes the MapReduce jobs are little slower than all other systems. Okay, it tries to execute your job no matter what. Okay, it tries to do all kinds of fail safe to make sure the work happens. Correct. So Girish says that when the streaming job executes by Hadoop, does Yarn is Yarn responsible to make sure that it passes to each data node? Yes. So whenever, whether it's a streaming job or normal MapReduce job, Yarn makes sure that your job executes close to data. All right. Now next question. Is everybody ready? Where does Hadoop store the result of reducer? In HDFS or in the local file system? Quickly. Local or HDFS? That's correct. So it actually stores in HDFS, right? If you remember, we were checking after we finished our word count, we went and checked our HDFS, not local file system. Now, next question to you is, this is a little tricky one. Okay, and okay, here, this is the one. Now, where does Hadoop stores the intermediate data, such as output of the map task? So when the map jobs have finished, the output of each mapper is intermediately, is it stored in the local file system on each node, or is it stored in HDFS, or is it always kept in only the memory? Okay, so if you remember that, so it cannot be in the memory, it cannot be completely into the memory. Why? Because imagine this, if you have got a big file and say there are two blocks on a machine, that means on that machine at least 512 MB is going to get consumed, right? Because each block is 128 MB bigger. And if your key value pairs out of MapReduce is of equal size as input, then it's going to consume at least 128 MB in the RAM. That means your data nodes are going to overflow. Okay, so it's definitely not memory. Now is left HDFS and local file system. Now, if say we keep the data in HDFS, it will get replicated and all of the magic will start happening. So, and we know that this data, this intermediate data has to be deleted after my reduce job has received the data. Once the data from mapper task reaches the reduce job, this data is this intermediate data is fairly useless. So do you think as part of design, if you were the architect of the Hadoop, would you keep it in HDFS or local file system? So Santosh says that I will store it in local file system. If it were in the memory, it will be an overhead. And since results are not finalized, it does not make sense to keep it in HDFS. Very good answer. Now Harian says it should be in the memory or local file system, but not in HDFS because it will result in unnecessary replication if it is in HDFS. Brilliant. Okay. All right. All right. So the answer is that it will be in a local file system. Okay. Temporarily, the data will be gathered temporarily into the memory, and it will keep on flushing it into the disk continuously. Okay. So whatever is the result, so your on one hand, your mapper is spitting out key values all the time. It's giving out key value all the time. And Hadoop is collecting these values. Okay, Hadoop is collecting these values and key values. And when Hadoop takes these key values in a batches of few key values, it will keep on pushing it into disk. Okay. Now, next question. Okay, Girish's question is, since we are executing job in Hadoop, how local file system comes into picture? So job is when we say Hadoop, Hadoop is actually going to execute things on various machines. And on various machines, it is the duty of the job whether to keep the data in HDFS or local machine. So job is absolutely free. Okay, but from our point of view, from MapReduce point of view, if we have to write MapReduce program, we would generally deal in HDFS. All right. So Anu's question is, are there any specific location on the local file system? It's generally in the slash tmp. Okay, slash tmp or slash where slash tmp are the location where all the temporary data is kept. Okay, so this question again, one more question to all of you. There are a few more questions, so be ready. The whole of the HDFS block available on a node is fed to the mapper. Is that correct or wrong? Okay, so the way HDFS block is cut is irrespective of the whether the boundary is in middle of the word or in middle of the sentence or middle of the line, it doesn't care. So HDFS block is a hard boundary of 128 MB. So whether that boundary lies in middle of line or middle of a sentence, it doesn't care about it. Therefore, Therefore, do you think if the whole block was fed to our mapper, will we ever get the full, we might get the half word, right, as the input, but we always got the full line. All right. So the input is split using input splits. This is what we are going to discuss today, and part of which is transferred to other mappers. All right. Okay, so this we have discussed yesterday, how to create a Java program, and we also have shown you how to run the test case. You have a look at the test case and you will understand that you can test your Java program without uploading it onto the cluster. Okay, all right. Now we have the here. Okay, so now talking about the input splits. If you remember, so on the bottom side, if you look at this, let's say there were these lines, line number, do not ignore this part for time being, it has nothing to do with these lines. Okay, so imagine this, you have got these 11 blocks, 11 lines, line number 1, line number 2, line number 3, line number 4, line number 5. From the disk point of view, it is going to be a continuous values, right? Because new line is just another character. So line number 1 followed by line number 2 followed by line number 3 and so on. Line number 5 seems to be a little smaller. Line number 6 is a little bigger and so on. Line number 8 is smaller and 9 is bigger and so on, right? Now if you look at it, block boundaries will be, if you see block boundary from here to here, it's same, exactly same. Only the last block is smaller. First block, second block, and third block is smaller. Okay. Now here that you can see here that the block boundary is lying in the middle of line number 5. Correct. So this line number 5 will be let's say 80% line will be in the first block, and rest of the line is in the second block. If you see from here to here, this is first block, this is second block. Same is the case with ninth block, because ninth is also lying on the boundary, right? So while the file was being stored, HDFS did not care whether 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 our block is being cut in the middle of line or middle of word or middle of character. It did not care, and it should not care, because at this point of time, while we were storing file, are not sure how are we going to process our data. Are we going to process sentence wise, line wise, or whatever manner we are going to process? Therefore, these are hard boundaries. Therefore, when you have these kind of hard boundaries, you cannot process the data as such. Okay, based on your requirement, you would like to parse this data, you would like to represent this data, and by default the text input reader, the text input which we get from Hadoop, it tackles the input by line, and 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 that is called the logical representation of your data in the form of input splits. We create the logical representation of the data in the form of input splits, and input split is basically designed such that we get the full logical data rather than half and broken data. All right. So input split is something which can control, which we can say that, okay, I'm using the line wise input split, or we want to deal with paragraph wise, or howsoever we want to logically process the data, we can accordingly use input split. Okay. If we are using say XML file, we can make sure that full node should come to one particular mapper, and other node should go to node as in XML node. If you have seen XML data, there is a node like in HTML, you have paragraph started, paragraph ended. Okay. All right. So we always prepare the input split on top of this raw data of the file. So Arvind's question is, if there is no space available to store line number 5, then also will it put 5 line into one block? Okay, so that's another deal altogether. If let's say on the first machine only, instead of 128 MB, which is from here to here, in, so there is a data node on which only 128 MB space is available, not 128 MB. In that case, this block will not go to that particular machine. Okay, does it make sense, Arvin? Correct. Now, Mandar's further question is, what if it's a video file or images? Very good. Because in those cases, the boundary definition is different than, than the plain text file, right? In those cases, you will have to tackle it using different kind of input split. We so far we have only taken care of text input split, and the default behavior of text input split is break down the text by new line. I hope this made sense to all of you. So input splits. So Hadoop divides the input block into pieces called splits. Okay. One mapper, the class of the mapper is instantiated for each input split so that it doesn't have to keep creating again and again for each record. So for each input split, one mapper instance is created and split contains records. Okay, what was the record in our case? Record were in our case of word count, a record meant a single line, right? A record is passed through the mapper. A record is passed through the mapper, and an input split is bunch of records. Input split is a collection of records, and each record is passed through the mapper, and mapper only gets one record at a time. Okay. Now this definition of record, definition of input split, we can control and customize. Okay. So if you try to create, so input split can be equal to the block size or closely equal to the block size, or it could be very small. So you could create an input split of, if you try to create very small input split, say input split is, one input split is equal to 5 lines, okay, or 3 lines. Now, if you do that, what will happen is there will be lot of data transfer, like in the previous example here, like in this previous example, on this boundary, when the input split will be created, this data, you see over this boundary, this piece of data is getting transferred to the node 1. Similarly, this piece of data, you see the extra piece of data, is getting transferred to the node 2. All right, from node 3 to form the input split. So if you create input split very smaller than the block, then there will be lot of data transfer that will happen. There will be a lot of overhead that will happen. Okay. Now, if you try, same case is true for if you try to create the input split far bigger than your block size. Okay. So if your raw block size is smaller than, very smaller than your input split size, again the data transfer will be too much. Okay. So generally the input split size tends to be very similar to each input, each HDFS block. Is everybody with me? Okay. So as we said, like the way we had dealt earlier, in case of word count, we got one line at a time. So one line, that line was a record. We call it a record. Okay. If we are dealing with HBase, and we are dealing with some database, each row is a record. A mapper function is given one record at a time, out of which your mapper function will derive the key values and give out the key values. And a record is basically a logical entity. It is not it is not something the way it's physically stored. It's logical entry, as in we have created a record out of our raw data. Okay, our raw data could be in XML format, but a record is a logical entity with the way we want to process our data. Okay, so input format or input split. So input format creates records and input splits. All right. So there are many default input split. The default one which we have used in our word count example is, so input format definition is the one which is responsible for creating input split. And what is input split? It's a bunch of records. And what is a record? Record is something like a single row or a single line. Okay. So text input format is the default one which basically converts your, for which each record is a single line. Okay, it reads your text file, creates input split containing multiple lines as records. Okay, now you can change the default delimiter by setting this particular parameter. If you do not want your input file to be passed by new line, you can say dot. Okay, and then instead of in our problem which we dealt in this class, where we were trying to parse our data and we were getting the text is, each record was a single line, and therefore we could not we could not match ram and happy, ram and birthday. Therefore, so because only one line is available to mapper at a time. Therefore, you might specify this delimiter as dot, and then you will get one sentence at a time. Of course, there will be many boundary conditions which you will face, such as what if dot is inside double quotes? What if dot is in the number? And so on. You could think of other things as well. Now there is another input format called n lines input format, which makes sure that on each input split we have only fixed lines. Okay, so always one input split contains fixed number of lines. Okay, this is not great if your lines are varying, as in line size is varying, then it's not great. Now Ud's question is that, is there a format class for a video input which would make sure that the video overhead information is available to all mappers? Yes, there are formats which take care of video, audio, or zip files. Okay, you can have a look at a little bit search. I have not gathered that information in this one, but there are already. Okay, because when I was even dealing with this geospatial data for national laboratories, they themselves, they also had one input split format for representing the geospatial data. Okay, now next question is, next input split input format is fixed length input format. Okay, fixed length input format, where we know that each record has got a fixed length, specifically in older format where we have fixed file formats, where each line we knew exactly that a record is represented by these many bytes. In these cases, the fixed length input format is useful. The content of a record need not to be text. It can be any binary data. The record can be binary data, and you can change the length of each the record you want to extract by setting the record length using fixed file input format dot set record. Now there is another one, key value text input format. If you are dealing with data that contains in each line key and the values, then you can use key value text input format. Okay, the input format of for plain text files, the files are broken into lines either /n or /r, and each line is divided into key and the value by a separator. Okay, and the separator by default is equal sign for the key and the value, but you can change it. If the separator does not exist in the line, that means the full line is the key. If okay, full line is the key and the value will be empty. Okay, so we have Hariharan's question. Can you give us use case of on image processing and video processing, like what goes as input to the mapper, okay, and map function? Okay, so let's take a case of image first. Okay, generally we would like to process the full image on a single machine, but sometimes we may want to process one layer on one node, other layer on other node, and so on. So there are various different kind of format. If you are talking about geospatial images, you can say to your input split that my each record means one layer of the image. Okay, so on one layer of the image will go to one node and another will go to another, and so on. So different there are generally, but when you are dealing with smaller images, you can basically use the normal the full image on our node, or you can split it pixel wise as well, that these many pixels go to this file, this node, and so on. Now, second point is, let's take a case of video processing. There are many different kind of input format. Some input formats say that give me split my video into each record such that each record contains 10 seconds video, or these many frames, 1,000 frames on each 1,000 frames on each mapper, and there on each mapper we can process those 1,000 frames. Okay, so Praveen's question is, for word count example we use key value text input format? No, we use this one. Okay, the text input format, that's what we use. This is the default one. Okay, because in case of key value you require the whole thing into key and value format. Although we could use it, but if a equal sign appears in the text, then it automatically will become the value. All right, did I make sense, Praveen? All right, Now there is another interesting file format called sequence file format. Sequence file format is great for reading sequence file. What is a sequence file? Sequence file is generally used to represent lots of binary formats. And interestingly, most of the binary formats have got a similar behavior. Most of the binary format are in the form of sequence file. And what does a sequence file look like? Sequence file is a flat file of binary key comma value. Okay, and each file has got a detailed header. Okay, detailed header as in the bit rate is, so if you take case of mp3 music, there will be a header saying what is the bit rate, who is the author, who has what is the genre of the music, and so on, that goes into the header. Okay, and rest is the binary data. Header also contains the size of the file. Okay, so those are generally, most of the binary file formats can be represented as sequence files. Okay, similarly, when you have to deal with very small files but there are millions of files, if you have to deal with such kind of scenario, then you generally prepare a sequence file. You generally prepare the sequence file, and basically the way it happens is that the header is shared with all the nodes, while the data with each one is part of only the part. Okay, so you can have a look at the sequence file input format if you are interested. So if you have to process very small file, okay, the general logical thing is to combine all of this data, all of these small files into a single file, create either a zip file, and then once you have created the zip file out of these small files, you convert that to the sequence file. Okay, there are many tools which can convert a zip file or tar file into sequence file. And once you have sequence file, you can load the data from a sequence file onto the to our map reducer. Okay, makes sense to all of you? All right. Any questions still here? Now, sometimes, so far what we saw was that the only data we got inside our mapper function was from the Hadoop infrastructure as input key and the value. But sometimes inside your mapper you want to read an external file, or maybe you want to read some other HDFS file. You can do that easily by calling filesystem.get and getting the file, getting that URL and accessing the file system. All right. Also, when you use, say, I was giving you an example just now where we were storing these small files into a into ggip into a compressed folder, right? When you have a lot of small files, you would not really like to create so many files. Imagine that there are a million file of 1 kilobyte each, right? For each kilobyte file, the metadata size is going to be the same. Therefore, your name node is going to overflow. So it's always advisable to convert very small files or combine very small files into a single gzip splittable format or LZO format. The quality of these LZO format is that you can decompress an LZO format in parts. If you remember, when you have a big zip file and you have splitted it during compression, you have created like 5 parts out of a zip file. And when you try to open one zip file, it will ask you all other parts. But that is not the case in case of LZO. In LZO, you can individually decompress the parts. You don't require the full file. Okay, you don't require all the parts. Therefore, we can basically decompress each individual block if they are in LZO format. And therefore, ggzip splittable or LZO formats are very much used when you are dealing with the data that requires compression. All right. So, did it make sense to you? Okay. Okay. I think it's a time for a break. Should we take a break for 10 minutes? All right, so should we start now? All right, great. Now return to full screen. All right, so now the next question is sometimes all available input formats may not suit you, and you may want to create your own input format. In those cases, you will have to use Java. Okay, if you want to create your own input format, rest of the things could be done in any of the things. Whether you want to specify different input formats, all of that could be done using even Hadoop streaming. But in case you want to create your own input format, then you will have to create. First, you will have to implement a class called input format. You have to extend it, and then you have to create your own own record reader, and with your own input split. The only thing is, while launching your MapReduce, you will say that my input format is your custom input format. All right, and that's what will change the way it works. So let me just try to open one Eclipse for you. Okay. All right. So some of you might be wondering, how does it work? So idea is very, very simple. So let me just take a screenshot of this one. And yeah, let's take a screenshot of this one. And okay. So this one, this from here to here is one block. Okay. Let's say, and from here to here is another block, and from here to here is another block. Okay. And let's say this is on node 1, this is on node 2, and this is on node 3. All right, these are the three different nodes. But when the mapper gets executed, mapper gets the full input split, which means that this section of the data is transferred from this node to this particular section of data is transferred from this node to your node 1. Similarly, from here this piece of data is transferred from node 3 to node 2, okay, and is given to your input split. All right. So how does it happen? So the simple logic is inside the input reader, like when we are creating input split. So here we start reading the data, we keep on reading the data. In case we have hit the boundary, we will stop. All right. And while starting itself, so when we are starting from here, in case it's not the beginning of the file, if we have not reached the boundary, okay, we will keep on giving the data to the previous node. Okay, so for this node 2, it will start from here and the till the point it reaches the first boundary, which is this. Okay, it realizes that till the point I reach the first boundary, I might be reading the record of the previous node. I mean previous split. Therefore, it will give that data, it will keep on skipping that data, and skipping means keep on giving it to the previous node. Similarly, so the same logic runs on all the machines. That is the input split logic, the way input split is created. So if you are not starting from the beginning of the file, okay, let's just talk about how would you design a text input split kind of text input format kind of input format. The simple logic will be that while creating the records, in case if you are not starting from the 0th byte of the file, keep on giving the data to the previous node until you reach the boundary. That means you are from here to here, you will be skipping the data, meaning keep on giving all this data to the previous node. Same is here. Make sense to you? Was I able to explain? Okay, so Praveen's question is how it knows about the previous node. So that's a duty of Hadoop while it's executing your input split to make sure that whatever data is being skipped by the node 2, it goes to node 1. Okay, now a very big question remains that does that mean that node 2 will not start processing the data unless the node 1 finish? Not necessarily. Node 2 will keep on skipping and Hadoop will keep on collecting that. Okay, so here, so imagine this. So from here, there is one input format creator, or we call it create record. I mean record reader. There are these three record readers. They will start their work towards, let's say, this side. Let me just try to. I'm not that great. So they will start from here and keep on reading towards the right hand side. All three of them parallelly on three different nodes while trying to create the records or trying to create the key value to be fed to mapper. Because if you remember, our mapper was also getting the input in the form of key and the value. So we are each record need to be created, and to create the record, all these three nodes will start running the record reader, create record reader parallelly, and this record reader will start from left hand side and will go to the towards the right hand side, and everywhere the logic of record reader remains the same, exactly same. So the logic here is, in case of text input format, that the logic is, if it's a beginning of file, if it's not the beginning of file, till the point, if it's not beginning of the file, and till keep on skipping the data unless you hit the block one, the boundary one, which means until we get a slash n, all the record, all the data will keep on getting skipped. Okay, unless of course it, because in case of the first one. Same case, had it been an XML file, we could have said unless you encounter angle bracket slash some node name, keep on skipping it for the previous node. Okay, that is how all of these processings happen. All right. All right, I hope you got the idea. So you can have a look in the example which we are talking just now. All right. So here you can see that we have created something called custom input reader. Okay. So this is our input format. We created something called n lines input format, which extends existing input format. And there we have overridden a function called create record reader. It basically returns our own n lines record reader, and here we have created this our own record reader which does the processing. It is supposed to implement these functions called close. So all these functions need to be implemented mandatorily. There's a duty of any record reader to close the stream, to give the current key, to give the current value, to display the progress, and to initialize. Okay. So here, if you see that if it's not starting, if not starting, then it does something. Okay. Otherwise, you keep on skipping the line until you hit a border. Okay, until, say, here what we have put in the logic is until you have read so many lines. Okay, so have a look at this. This should give you a good amount of picture, and it should give you a good amount of idea, like how do we generally create our own custom input reader. Okay, and once you are done with modifying, creating your custom input reader, you can go to your mapper class here, not mapper, the driver class. And there you can say things like set input format class as your class name. Now, instead of using text input format, it will start using n lines input format. All right. Great. So have a look at this code. And this is a very important code and you will like this. So there are two projects. This is the second project in the session number 5. All right. Now going forward. All right. Now a little bit recap of the way we were processing data. So again, now you it makes sense to you, right? This is split 0. So on top of each block, we create these input splits, split 0, split 1, split 2, and that split record by record is fed to mapper, and mapper gives out the key values. Those are sorted on each machine, here, 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 and once the sorting has finished, they are all merged on a central machine and then passed to the reducer, one key at a time with all the values for that key, and whatever is the result of reducer goes into this part 0 file. So that's a story about single reducer. Okay, any questions about this diagram? Also, there are a few more information. This dash, this strong arrow represents the network transfer. So this is a network transfer, this is a network transfer, this is a network transfer, while dash is a local transfer. meaning on the same machine we are transferring the file. And these dashes represent the node. Is it clear to all? Now, next diagram, again, it's a recap. So same thing, everything is same, just that when the mapper is giving output, it is being put into two buckets. Now, who decides? How is it decided that a particular key will go to the first bucket or it will go to the second bucket? How will it get decided? Okay, that is the role of partitioner. Okay, now specifically, if you see this in usual manner, one word goes here, second word goes here, third word goes in the first bucket, fourth word goes in the second bucket, fifth word goes in the first bucket, and so on. Okay, that's how in the usual manner it happens. It tries to create a hash value such that the words are uniformly distributed. Okay, but no matter what partitioner you use, you have to ensure that if say key called apple in on this machine went to first node, apple on the second node should also go to the first bucket. If it has gone to first bucket on the first node, then same key should go to the first bucket in the second node as well as on third node. Copy seems to be costly if map and reduce are not on the same node. That's correct, Damodran. This copying is actually costly affair. Okay. But since it's happening in the network, parallelly the things are happening. Therefore, this copying will not, although it will be a big task, but it will not still pinch too much. Now, Damodaran's next question is: did you have an experience in a situation where map cluster and reduce cluster on different routing domain? No, we do not specify that reduce domain have to be completely different. Okay, as long as so, I mean, the more important thing would be how is the routing, as in if you have a disparate network, meaning you have subdomain, you have top level domain, and so on. In all these cases, so there could be a scenario where some nodes are far away from some other node. Those that is a topology part. We will discuss it. We can tell Hadoop that these two things are far, far away. Therefore, be cautious about it. That's defining your topology. All right. Now, to decide whether a particular key goes to first node or second node, we can define our partitioner. We can say, let's take a case of age partitioner. This age partitioner basically it gives out a number between 0 to n being the total number of reducers which we have specified. So for every job we specify that it has got these many reducers, right? So, and for each key the partitioner decides whether this key has to go on the first reducer or the second reducer or the third reducer or so on. So that role is being played by this function which returns a number between 0 to n being the total number of reducers. And the input to the partition function is the key, the value, and total number of reducers configured. All right, this is how we define the partitioner. There is one more example here in this case. you will see there is a not char count. So here is my partitioner. If you see what I have done here, it's a little bit. So I'm trying to do the word count such with two reducers. I'm trying to do the word count with two reducers such that the output of reducer 1 contains only the words starting with 0 to j. Okay, 0 to j. And in the second file, I'm trying to keep only the words which are k to z. And that's what I have done here. I'm telling the get partition function say that if the first character of the key is lesser than k, send it to 0, which means the first reducer. Otherwise, send it to the second reducer. Now, the output generated by this MapReduce function will be two files. For each reducer, there'll be one file. Therefore, there'll be two files for each one for each reducer. And if you concatenate these two files, you will get a single sorted file. Why? Because I have made sure I have done the partition such that all the values starting lesser than k, all the words which are starting lesser than k go to first reducer, and all the words after k go to the second reducer. That means individually anyway, the Hadoop makes sure that whatever keys go to the reducer, they are sorted. Therefore, I mean, if all the keys are sorted, therefore, these two files can be concatenated, and you will get the end result as sorted data. All right. So, but we talked about blocks. I did not get Praveen. So we are talking about this particular point on what basis a key goes into first bucket and second bucket. All right. Is everybody with me? Okay. So partitioner is clear to everyone. All right. So, okay. Now, this was the question which we had already tried to address. All right. So by default, there will be one reducer. Okay. How many reducers are there generally? By default, there will be one reducer. But we can tweak the number of reducers while launching our job, saying if there are too many reducers, if we try to tweak the job and we create too many reducer, the overhead might become too high. If there are too few reducers, the computation might take more time. So we'll have to do a little bit tuning to fit the total number of slots, and slot are same as what we had discussed already. All right. Okay. So Praveen's question here is, so these are buckets. If you see here, all right, let me just try to put an arrow. So this is a bucket. This is a bucket. So, yeah. So this is one bucket. This is another bucket. Okay. So this first bucket goes for first reducer, second bucket goes to second reducer, first bucket goes to first reducer, second bucket goes to second reducer. All right. So basically each bucket is for one reducer. So this is a bucket here. Okay. Makes sense to all of you? All right. So that was how we do the partitioning and decide upon number of this. Now there is very important aspect called combiner functions. Sometimes, because as we noticed here, this transfer from mapper to the reducer is a very costly affair. So can we compress the data? Can we do some sort of reduction? Can we reduce some data before it gets transferred from mapper node to reducer node? All right. And that's where the combiner functions come into play. Now you can see that there is a node 1, there is a node 2. Node 1 is running some mappers. The output of mappers on the same machine. So here we have a single machine, again and again map function is being called. The output of it is being gathered on the same machine. Before sending it to the reducer, we can pass this data through the combiner. Before sending it to the partitioner, we can send the data through the combiner so that we can compress the data, trim the data, correct the data, whatever we want to do on each node we can do. And this logic is similar to the reducer logic. We write a function, even the signature of the function is identical to the part to the reducer logic. And also note here that combiner gets executed before the partitioner, before it's decided whether, before the shuffling, as in carrying bucket from one node to another, before the shuffling, the partitioner get executed. Okay, so this mapper function converts multiple key values into single value and so on. Okay, so it runs on the same node after map has finished, processes the output of map, helps in minimizing the data transfer, but it does not replace the reducer. Okay. Abhishek's question is, you had written the partitioner for output of reducer. No, no, it was output of the mapper, not reducer. Sorry. Here, did I say that? Partitioner takes only the input from combiner, okay? Not from the reducer. No, actually here, do you mean this one? No, this is the same partitioner. Okay, same partitioner. We defined it here, and in the our driver, we can say, have we done it yet? No. We can say something like job dot set partitioner. Okay, set partitioner class, and we can say stub partitioner. All right, we can say things like this. Oh, we already have this line, you can say. Yes. So combiner essentially means, that's very correct, Damodran. Combiner essentially means a mini reducer functionality within the mapper. All right. Now there is just one tiny little catch, and that catch will be a little difficult to understand. Not all functions qualify to become combiner, because in the combiner does not wait for all the values for a key to gather and then run combiner on all those values in a single shot. Instead, instead it will combine as and when it finds the values. Okay, so a combiner has to be a combiner has to be something like this. Okay, so a combiner has to be such that no matter in what way it is applied, the output should be same. Let's say there are four values, 0, 20, 10, and 25 for a single key, and we want to combine these values using our combiner. What which essentially does is it does the maximum. Okay, so whether this function called max applied on all four values in a single shot, or first max was applied on 0, 20, and max was applied on 10, 25, and whatever is the result is given to max again. And so no matter how our max function is applied on these four values, the result will always be the same, whether we take 0, 10 first and to 20, 25 first and then apply max, or we compute the max of these three values first and then again apply max on rest of the values. In no matter in what permutation or in how many times we apply max, the result will be the same. Okay, the result will be the same case is for mean, and same case is for sum. Okay, so the combiner has to have these property. Therefore if you see computation of the average is not a function that qualifies to be a valid combiner. Okay, so if you say average 0, 20, 10, 25, you will get 11.25. Now let's compute the average of 0 and 20, 0 and 20, and 10 and 25, and then we'll compute the average of the output, which is 13.75. It's not 11.25. Therefore, if you try to put average as your valid combiner function, it will lead to us wrong results. Will give us wrong result. All right. Now, a question to you is that this particular function, the way this function is combining all these values is by doing square root of a square plus b square plus c square and so on. Okay, so a function which returns a square root of summation of squares is such kind of function a valid combiner? Can anybody tell me? Is this function a valid combiner? Are you sure? A function. So can we apply function ABC again and again on values and still the result will be the same? So Urs is saying that you could do the sum of the square in the combiner, but a square root in the partitioner. How will you do the square root in the partitioner? In case of a partitioner, you only get one key value at a time. You don't get multiple key values at a time. Damodran says the combiner does not necessarily be used. Okay, so does it mean, do you mean that it's not a valid combiner? So Hariharan says that he tried an arbitrary sample for AB this function. It looks like a valid combiner. And the matter of fact is it is a valid combiner. Okay? That's a matter of fact is, let's see what happens. Okay? Let's say we got A comma B comma C and comma, let's say this one only. Okay? So let's apply our combiner function on these two values. What will be the result? Let's call the result as z equals to square root of a into a plus b into b. Okay. Now out of j comma c, the result will be square root of z comma z plus c comma c into c, not comma, c into c. Okay, which essentially means, now let's try to replace z square with a square plus b square. So this is z square, right, which is equal to a square plus b square. Now you see, if you try to take three values, all these three values together, the result will be, okay, so this is approach 2, and in case of approach 1, the result will be, let's say all three values came together, we could say b into b plus c into c. All right, make sense to you? So the result at the end of day is same. That means it's a valid combiner. You could try more permutations and and therefore you will find that this is a valid combiner. It's a difficult question, and I have seen even the experienced people not being able to respond to this question like, and actually an interesting question. Okay. All right, so that was about the combiners. So combiners help you a lot, just that you have to ensure that whatever you put in the combiner, it should be having these properties. Okay. All right. So another question which people keep on asking, that if we have jobs, multiple jobs having mapper and reducer. Okay, Shrisha, are you there? Because I think you were asking this question. All right. So generally there is this problem where we have, if you remember our question number fourth, that unusual democracy, there we had multiple basically two phases of MapReduce. So when you have to do the job chaining, the most simple way is doing creating two jobs. The way we have created only one job, we could create two jobs. And here, instead of saying job dot wait, we first let it finish, and then we could say job 2 dot wait for completion. That is another way of saying, which means finish the job one first and then execute job 2. So that is one way of execution. S- Okay. Second way could be using ampersand. If you have tried this, let's say, let me increase the font size, and if you try to say here, so if you say echo high and ampersand and echo high, so you can see that the second gets executed only if, and let's say I'm saying rm this. Now, if you see, it did not get, second statement did not get executed. So the second command, these are the little tiny utilities provided by Unix, that if you have to make sure that second command gets executed only if the first one runs, then you write them in the format cmd1 ampersand cmd2. Cmd2 will get executed only once cmd1 suffices. Cmd1 finishes, not suffices. So in the same way, you could also run your two Hadoop jar commands. Okay, that's a second method. Third method could be using an external workflow manager such as Oozie. Oozie is like your Apache Ant, where you could say that once this finishes, do these things. Okay, now method number four could be using something called depending job. We could say job to dot add depending job. Okay, so job 2 cannot, you cannot start the job 2 until job 1 completes. Okay, I've created a separate project for this. Have a look at the project. You will have a thorough clarity on how to use dependencies, how to do the chaining of the job. So Damodaran, this Hadoop, the ampersand is not a property of of Hadoop. It's basically a Unix way of executing things. And ampersand basically runs things serially, while single ampersand makes things run in the background. All right. All right, there is another concept so one way of executing MapReduce was using streaming. Second way was using normal Java code. Streaming was nothing but internally it was using the usual MapReduce. Now, Hadoop also has provided another way of executing jobs via pipes. So, generally, when you have to run C++ code, running it through pipes is a very, very useful thing. Okay, running it through pipes is a very, very fast and better way of executing C programs. Okay, so you can run your job like this: Hadoop pipes, input this, output this, and program name is this. All right, that is how the pipes work. All right, now another concept which is quite popular in interviews is speculative execution. So in order to make things faster, Hadoop did lot of optimizations. One of those optimizations was speculative execution. Okay, so speculative execution is that if one particular task is taking too much time,